Picture this. The gate swings open on a cold Oklahoma morning in 1993, and 300 bison step out onto a landscape that hasn't felt their hooves in over a century. No fanfare, no ceremony. Just the low rumble of 2,000 pounds of muscle moving through chest-high grass, and the slow, enormous machinery of an ecosystem beginning to wake up. The Joseph H. Williams Tallgrass Prairie Preserve, the largest protected tallgrass prairie remnant left in the world, had been waiting for this moment. The Nature Conservancy had spent years acquiring the land, drawing up management plans, running the numbers. Scientists and land managers thought they had a pretty good picture of what would happen when the bison came back. They were right about some of it. They were spectacularly wrong about the rest. This is the story of what the prairie did when nobody was watching. The tallgrass prairie, like the bison, was once a common sight, an ecosystem that reached across 14 states. Now just 4% of that grassland remains, and the majority of it is in Oklahoma's preserve. To understand why the bison's return mattered so much, you have to understand what the land had become without them. For a century, this stretch of northeast Oklahoma had been cattle country. The grass grew, but it grew uniformly, tall, thick, and monotonous. A green carpet that looked lush from a distance but was, ecologically speaking, nearly silent. Cattle tend to cluster around water and graze nearby plant species, creating vast swaths of overgrazed prairie with little cover or tall vegetation. Unlike cattle, bison roam. They graze in wide arcs, moving farther from water and eating a bit of everything no matter the grass species. This non-selective far-ranging behavior creates a patchwork of tall and short grasses that supports a wider range of plant and insect life. That patchwork is everything. Imagine the prairie not as a single green surface, but as a mosaic, short-cropped areas where bison have recently passed, mid-height zones left alone for a few weeks, and tall, dense stands that haven't been touched for months. Each patch is a different microhabitat. Each microhabitat tells a different story, and the bison are the authors of all of it. Bison followed fires to graze on tender new growth of grasses and sedges. As they fed, their hooves aerated, and their manure fertilized the soil, giving rise to abundant wild flowers. The Nature Conservancy knew this going in. They combined the bison with prescribed burns, a management strategy scientists call pyrrhic herbivory, deliberately combining prescribed burning with bison grazing to mimic historical patterns. Research has documented that this fire-grazing interaction increases habitat heterogeneity and biodiversity across the landscape. But the scale of what happened to the plants, that was the first surprise. Compared to ungrazed areas, reintroducing bison increased native plant species richness by 103% at local scales and 86% at the catchment scale. Gains in richness continued for 29 years and were resilient to the most extreme drought in 4 decades. These gains are now among the largest recorded increases in species richness due to grazing in grasslands globally. Double the plant diversity, not in a controlled lab, on a real working prairie over 3 decades. Dozens of native plant species returned to the prairie that hadn't been seen there in living memory. Flowering forbs, the non-grass plants that look like weeds to the untrained eye, but are the foundation of everything that lives above them, began pushing through the soil wherever bison had recently grazed. The grass was no longer a monoculture, it was a garden. Now here is where the scientists started getting genuinely surprised. They expected the plants to change. What they didn't fully anticipate was how fast the change would ripple upward through every layer of the food web. Think about what a diverse, patchy prairie means for insects. Every different plant species is a different food source. Every different grass height is a different microclimate. And insects, it turns out, are exquisitely sensitive to both. Research at the Tallgrass Prairie Preserve documented increased diversity of butterflies in bison-grazed areas compared to cattle-grazed or ungrazed areas. And it wasn't just butterflies. Even small, often overlooked species benefited from the bison's return. Dung beetles specialized in processing bison waste. And these insects in turn supported insectivorous birds and mammals. The bison were also doing something else, something that nobody had really thought to model in their management plans. They were wallowing. Bison affect their environment by wallowing, rolling on the ground repeatedly to avoid biting insects and shed loose fur. This creates long-lasting depressions that further enhance plant and insect diversity because they are good habitats for plant and animal species that are not found in open areas of the prairie. These depressions, ranging from 10 to 15 feet in diameter and up to 2 feet deep, persist for decades or even centuries. When it rains, wallows collect water, creating ephemeral wetlands that support unique plant and animal communities. Here's the twist that the research revealed. Abandoned wallows had higher arthropod abundance seasonally and higher species richness in several feeding groups. The impact of wallowing is dependent on time since occurrence, with long-term effects creating patches of higher arthropod abundance and richness. These patches are likely important, at least seasonally, for other consumers higher on the food web. So the bison weren't just grazing a patchwork into the grass, they were stamping a second layer of patchwork into the ground itself, a slow-motion architecture of pools and bare earth and recolonizing vegetation, each wallow becoming its own tiny ecological experiment. Which brings us to the birds. And this is where the cascade gets really interesting. So here's a question worth sitting with for a second. If you were a land manager in 1993, would you have predicted that releasing 300 bison would eventually change where hawks hunt? Comment your answer below, because what happened next caught almost everyone off guard. Research suggests that the presence of bison has an immense positive impact on the recovery and presence of prairie songbirds. Due to the lack of consistent tree cover, many grassland birds nest on the ground or in low shrubs. They rely on cover from vegetation to hide from predators, nest, and hunt. So the uniformly short grasses of cattle pastures pose a real issue to these species. But in a bison-managed prairie, the story is completely different. Grassland birds show strong preferences for different stages of the fire-grazing cycle, with some species favoring recently burned areas, while others require patches with taller vegetation that haven't been recently grazed or burned. The bison were, without knowing it, running a hotel with rooms for everyone. Short grass specialists moved into freshly grazed patches. Tall grass nesters moved into the undisturbed zones. Species that hadn't been seen on this stretch of Oklahoma prairie in decades began showing up. Grassland obligate bird diversity was lowest in recently burned and ungrazed management units, but in burned and grazed units, researchers did not observe this loss in diversity. The Henslow's sparrow, a species known to be sensitive to recent prescribed fire, had increased abundance with time since fire, and this increase was further amplified with bison presence. Grassland birds like the greater prairie chicken, a type of grouse that has lost much of its native habitat, are of particular interest in these preserves, and their return is not incidental. It is a direct downstream consequence of the bison reshaping the grass, which reshapes the insects, which gives the birds the food and cover they need to breed. Some bird species, like cowbirds, evolved to follow bison herds and feed on the insects they flush while moving through grasslands. Picture a herd of 2,000 animals moving through tall grass on a summer morning. Every step flushes grasshoppers, beetles, and moths into the air. Birds trail the herd like a living wake, picking off insects in midair. This isn't a new behavior. It's an ancient one, dormant for 150 years, suddenly switched back on. And then the predators started to shift. The presence of bison herds dramatically changes how predators and their prey interact across the landscape, creating what scientists call a landscape of fear. When coyotes are hunting bison calves, smaller prey animals like rabbits and ground squirrels experience less predation pressure because the predators are focused on the much larger, more rewarding targets. When bison are absent, all that predatory attention shifts to the smaller animals, increasing their stress and changing their behavior patterns. Think about what that means in practice. More small mammals moving more freely across the prairie, different corridors of activity, different zones where raptors choose to hunt. The hawks are not responding to the bison directly. They are responding to the ripple, to the changed behavior of the prey that the bison displaced the predators from. 3 links down the chain, and the whole predator-prey geometry of the preserve has shifted. These complex relationships highlight the concept of ecological memory. Even after long absences, ecosystems can sometimes recall and rapidly re-establish these evolutionary partnerships when keystone species return. That phrase, ecological memory, is what makes this story so much bigger than a conservation success. The prairie remembered, the insects remembered, the birds remembered. Relationships that had been severed for over a century snapped back into place with a speed that stunned the scientists watching it happen. In 1993, Oklahoma oilman Kenneth Adams donated 300 bison to the preserve. By 2000, the herd had increased to 1,200. In 2025, the preserve counted a total of 2,025 bison, with 486 calves born that year. What started as 300 animals is now a self-sustaining, thundering presence on nearly 40,000 acres. And every year, the cascade deepens. More wallows age into insect-rich microhabitats. More plant species return. More birds find the structural diversity they need to nest. As one lead researcher put it, bison were an integral part of North American grasslands before they were abruptly removed from over 99% of the Great Plains. This removal occurred before quantitative records, and therefore the effects of their removal are largely unknown. What the Tallgrass Prairie Preserve has given scientists is the reverse experiment, a chance to watch the removal in reverse, in real time, at scale. And the lesson is this: ecosystems are not passive. They are not simply broken things waiting to be fixed by human management. They are ancient systems with latent potential, coiled and waiting. Sometimes all it takes to unlock 30 years of cascading recovery is to open a gate and let 300 animals walk through. The prairie knew exactly what to do. We just had to get out of the way. If this story made you think differently about how ecosystems work, or if you want to see more deep dives into the science behind conservation, wildlife, and the natural world, subscribe and hit the bell. There is a lot more of this to come.